Hi, and welcome to the Scientist's Toolkit. So this is a series where I am talking to you about some concepts that I think are important to understand science and how we do science. Um, so one of the topics that I really wanted to get right off the bat is scientific publishing and how is that process, right? Um, so when you look at a news article or reels on Instagram, even if TikTok, sometimes people will have their sources, right? So that's good. That's a good time. But how do you decide if that source is any good or not, right? And in scientific publishing articles, any output really from science, you need to understand that you're human doing science. We're human beings trying to do this. So it's kind of the same as any other profession, right? You have good doctors, bad doctors, you have good photographers, bad photographers, and not necessarily only good or bad, right? You have different levels of experience, you have different expertise. So, for example, an oncologist is probably not a good psychiatrist, and vice versa. And for you to understand that, we need some kind of outside evaluation from it. So of course, if you're looking for a doctor, that's a bit easier. You're going to look at, talk to your friends about it. You're going to look for recommendations. But if you don't know anyone, then you're going to look at, for example, reviews, right? You're going to look at reviews on Google Maps, or you're going to look at reviews or, you know, um, anyone just expressing their opinions about it, even if it's not someone close to you. Of course, that level of evidence for you or for myself, for example, if I have someone that I know, someone from my family, one of my friends saying that, that doctor is good, I probably take their word more seriously than a stranger that I don't know and that, I don't know their understanding of what is good or not. And this is true for everything. But then for science, what we have tried to do over the years is that we have this process that's called peer review. So if you're a scientist, you want to publish your work, you prepare a manuscript and you send out to a journal. And then these journals, they're going to have a process of peer review where they're going to invite other scientists to look at this work and then tell you, okay, is this worth publishing or not? In terms of, is this new? Is the methodology sound? Right? What the scientists here are saying, is that true, or can they even say that based on the evidence that they have, and so on. So this is an interesting and not at all flawless process, right? But it is good to know, and this is considered gold standard for publication in good journals, right? Because at least you have some kind of understanding of what is the quality of that work, of that scientific paper. Okay, so let's say, I'm a scientist, I just finished my work, I had this research question, I went through the scientific method, and I found some results. So I want to publish those results. I prepare my manuscript, I send out to a journal. So it can be any journal really. There are hundreds out there. Of course, there is also different tiers, right, of journals. So you've probably heard about the top journals like Science, like Nature journals, right? And you have many others sometimes within an umbrella of one big publisher like Nature and Science. But let's say I chose the Nature journal. I'm going to send out my manuscript to them, and that will go to an editor's desk. So the chief editor usually will be the one that's going to look at that paper first and is going to decide, okay, does this even make sense for our journal, right? Is it within the scope? Is it interesting for our readers, right? So there is a little bit of opinion as well of that journal, if this is an interesting research or not for us to publish, as would be with any other non-scientific journal or newspaper. Okay, but let's say that editor says, okay, this manuscript has potential, it's something that we're interested in, so let's send out to peer review. At this point, it will usually go to associate editor, right? One person that cannot do everything. So you have other editors that are going to be sending out this paper for peer review. For peer review, then you choose at least two, but sometimes it's many reviewers that you think are going to cover the knowledge base that you need for someone to understand if that's a good evidence or not, right? So often you'll choose someone that's a specialist in that field, but you can also choose someone that's a specialist in statistics to see if the statistics of the paper is sound. And really it will depend on what is that paper on, right? If it's on oncology, then we're going to choose an expert in oncology, and so on. And we're going to invite reviewers to do this. Unfortunately, reviewing is usually a voluntary process. So it's hard to find reviewers. It's hard to find people with time and dedication to do this. But we do, as a community, want to help papers being published, because at the other hand, we're also the ones trying to publish, and we need reviewers for our manuscripts as well. So once these reviews are found, right, this is the reviewers are gonna look at the paper. They're gonna give their concerns or their praises and send this back to the editor. Then the editor will decide what to do with this paper, right, based on this feedback. Is that feedback good? If it's consistent across all reviewers, then you have an indication that, as an editor, that okay, probably this is the truth about this paper, but it's not guaranteed, right? And sometimes we'll have conflicts. Sometimes the person from the statistics is saying, oh, this paper is not good at all. There's a lot of flaws in the statistics, but then you will look at the answer from the oncologist, for example, and the oncologist researcher is saying, oh, this is sound, like this is a good research question, this is a good method. And then you need to conciliate those things. And then as an editor, you have three choices, right? You can simply reject that paper, or you can accept it, or you can ask for revisions. So if you accept it as it is, then it means that everything was flawless. This is all of the times, I would say, almost all of the times not the case. And sometimes we'll have some revisions, so they can be minor or major revisions. So minor revisions would be the editor is asking just for some changes, and some places where you've explained maybe too little about it or too much about it, or you're missing some references, things like that. Or you can be a major revision. You can ask for new experiments. You can have for new ask for new analysis, and you're just gonna change the paper itself and the manuscript in an extensive way. Well, after that, then if you've been if you as an author then have been asked for revision, you're going to try to answer to all of those questions maybe that reviewers had, or you're going to try to make the revisions or the changes that they've asked. And this process can take months. Usually it takes months, sometimes years in some cases. But the bottom line is you're getting closer and closer to a better result, right? Like you're getting closer and closer to better evidence that you can put out there. And at the end, then, of course, you have a final decision. If you have been asked for revisions, usually then the paper will be accepted as long as you've done everything that the reviewers have asked and that the editor wanted. And then only then this process is finished and the paper is ready for publication. And we as readers, as scientists, or the community as a whole, we have an understanding that if it went through this peer review process, then we trust it a little bit more. It doesn't mean that it's flawless, as I said. It just means that some other researchers try to look, impartially to it. And hopefully we're going to have a better result. But then impartially, it's also interesting because you can have different types of reviews. So some reviews are completely open, so they're going to even be published. All the comments of the reviewers, all the responses from the authors, they're going to be published together with the paper. This is somewhat of a new development. So back in the days, it was usually only a blind, completely blind process, which in a way ensures, of course, that we're going to try to have less bias, right? So it was a way to try to ensure less bias. But that's not truly the case necessarily, right? So you would send out the manuscript, and the reviewers wouldn't know who the authors are. The authors mostly don't know who the reviewers are. But then for some fields, of course, this is quite tricky, right? There are some fields that are small, so if you know that the data is coming from a specific part of the world, you know that that's the group that's working on that. So you kind of know who did that study. But in any case, of course, a blind review is interesting because you don't want to have any kind of bias, right? So you don't want to have a bias, oh, this came from a underdeveloped part of the world where we probably think that research didn't have enough funding and therefore is not good. That's not true at all. We have very good research being conducted in low and middle income countries. Or then you can also have the opposite going on. You look at it and you see that it's from a very prestigious university, a very well established researcher, and you might be a bit lenient on it, right? You're gonna cut some slack, or just unconsciously not look that much into it because you just trust the source. And that's also not the way to do it. So there are, of course, 100 caveats in this and pitfalls that I could go into. But anyways, this is the process that will ensure that things that the manuscript is of good quality and that it can be published, and that the papers that are gonna be out there are of a good quality for people to read, and that the evidence is well presented. Okay, not all journals will be peer-reviewed journals, right? So we have some journals that don't have that, or sometimes they're not even called necessarily journals, but we have, for example, something that has been developed in developing development lately, which is preprint, right? So that's something that's it increased mostly during the COVID pandemic because we needed this process to be fast. And from what I just told you, peer review is not fast. It takes a long time for you to find people that are willing to do this and for them to have the time also to look into the papers in detail. So when we needed things out there fast so that we could look at the information, it's very useful to have preprints. So preprints is precisely that, like you're putting it out there before it is ready for print in a reputable, I would say, journal that has a peer review. It is good because you have the information out there, but then it's also bad because you have that information out there. Because of course there will be no kind of filter, right? I could publish anything. And of course, you have the community for that, and you have trust in the reader that they can understand what that paper is presenting, and that they can decide for themselves if that's good evidence or not. But I cannot decide for myself, even being a scientist, because I don't know all of the different fields, right? I cannot really read a physics paper, although I really like physics, but I cannot really just read it and understand everything and even see if that's a good method or not, if that's a fair statement that they're putting out. Well, 100 million problems with it, and I could just make a whole video about it. But the point that I'm trying to get at is that we have peer review for a reason, and it is good if you know that that paper has been peer reviewed or not, and that it is in a journal that has peer review, right? So this is important for you to know that the evidence is probably higher than simply a preprint. Okay, then it makes it think that, I don't trust all newspapers out there. I don't trust all media sources. Should I trust all scientific journals? And the answer is obviously not, right? We have what we even call predatory journals, that are journals that are trying to get your money for publication, because there is a lot of money involved in this. So you can have two different kinds of journals, main different types, which would be an open or types of publication, let's say, because sometimes journals are hybrid, but you can have a subscription type when the readers are the ones paying for that content. So me as a researcher, when I send out my manuscript and I get it published in that journal, I don't pay anything. But then my readers will pay for reading that content. So it is a subscription base, right? So either you have a good subscription or you'll buy each article separately. And that's good for the researcher because we don't have to pay, but it's obviously not good for the readers, and it becomes inaccessible to the general public. So we have also now open science strategies that are trying to change this, and a lot of journals will be open. And in this case, then usually me as a researcher, I need to pay for the editorial process to get my paper out, but then anyone can read it. It will be available for everyone, just, any community, just to, all you have to do is go to the website and read it, basically, right? Okay. So this is open access versus subscription. Good or bad? Not necessarily. As I said, some journals will have both in the same journal, and you might have different reasons for that. Mainly money, but not necessarily only. But it's not only that. You just have different tiers of journals. So as I said, you probably know nature journals, you know science journals, but we have many other ones that are good and some other ones that are not that good as well. And how do we categorize them, and how can we say if they're good or not? That is a huge discussion. Because one of the things that we use a lot and still, I guess, could be considered as a gold standard is journal impact factor. But that doesn't really say much about the quality of it. It says a lot about how many reads you have. So if I'll give you an example of this, I'm going to this website, right? So this is Clarivate. So it says here that Clarivate, they started doing this in 1975. They published a journal citations report, and that's basically what it is. It's a measure of citations per number of articles that journal had. So the example that they give here is a quite old example, but so if you want to see the journal impact factor, so it's always considering 2 years at least. So if you want to calculate the impact factor for 1992, then you're gonna see all the articles published in 1990 and 91, see how many cites they have, citations, right, in 1992, and then divide it by the number of articles published in 90 and 91, right? So again, if that wasn't clear. So if you're looking for the journal impact factor for 1992, you're gonna sum up the number of citations of all the articles from 1990 and 91 divided by the number of articles published in 90 and 91. But then there is a caveat here as well, because in the denominator, you just have the citations of all the articles published in these 2 years, right? The two previous years. But in the denominator, it's only what they call citable articles, and that does not include editorials and also not letters to the editor. Editorials and letters to the editor, they're more opinion pieces. So they're not really, original research articles or even not even reviews. They are, you have something to say about something, and you will write a smaller piece that's 1 page, 2 pages about a topic, or even sometimes about another paper that has been published, right? But that will not count in the denominator. It does count in the denominator though. So this is actually a strategy that some journals will use, where they have many editorials or many letters to the editor, because they are going to be cited, and these citations are basically free citations when you look at the journal impact factor, right? So you need to be careful. Of course, there is a lot of ways to just cheating the system, and that's true with everything, really. All right. So, was I looking to the wrong camera? I was. I am really sorry. Um, Anyways, so this is, I guess, all that I would like you to know for now, and all that's needed for looking at how journal articles are published. But be, aware of these differences. Not all journals are the same. And an easy way to do this is, if you're interested in a journal, for example, journal Nature, right? Then you can just go here. Oh my. And you can go to the journal metrics. So all of the journals will have something like this, where they'll tell you their metrics. You can simply go to the, front page, and then you'll have about the journal metrics. And you'll have some information about this. It's not perfect, but it's something that you can use to understand, this is a very high impact factor. But then again, this will depend massively on the area of the journal, right? Because, science has many different areas, and they vary in amount of people studying them and an amount of people interested in them. So, for example, medicine has the highest impact factors just because a lot of people are interested in medicine. We need this for survival. We need this for improvements for our own lives. And maybe not that many people are interested in, particle physics. So this is something that you should keep in mind.